Hello everybody and welcome to exercise 4. We are looking at page 60 in the workbook here. Let's take a minute to read what this question is asking us here. Okay, so suppose that H and K are subgroups of G such that the order of H is 3 and the order of K is 5, and they would like us to determine what the intersection of H and K are. Okay, well, this is a problem that we can do using Lagrange's theorem if we think about it in the right way. Okay, so we're going to start with an observation from a previous homework problem that tells us that if you take the intersection of two subgroups, you get a new subgroup. Okay, so by a previous homework problem, we know that H intersect K is a subgroup. Okay, so at least we know that. They're asking us to determine what that subgroup is. Okay, well, here's the thing. We know that H intersect K is a subset of both H and K, so we're going to look at those two facts one at a time and just see what information that gives us. Okay, so for example, the fact that H intersect K is a subset of H implies that H intersect K must be a subgroup of H. Okay, because of the observation that we made above that H intersect K is a subgroup. Okay, but if H intersect K is a subgroup of H, we know from Lagrange's theorem then that the order of H intersect K has to divide the order of H, which we know to be 3. Okay, so the order of H intersect K is a divisor of 3. Okay, and we can make a similar argument with H intersect K and K. We also know that H intersect K is a subset of K, and therefore a subgroup of K. So the order of H intersect K, again by Lagrange's theorem, has to be a divisor of the order of K, which is 5. Okay, so let's put those two things together then. We know that H intersect K is a divisor of both 3 and 5, but what's the only common divisor that 3 and 5 have? Just 1, okay, because the GCD of 3 and 5 is 1. And so let's say it this way. Since H intersect K, or the order of H intersect K, is a common divisor, of both 3 and 5, we must have the order of H intersect K being equal to 1. Okay, so this subgroup has just one element in it. Okay, what could that one element be? Can you think of an element that has to be in every single subgroup? Okay, every subgroup has to contain the identity, so if there's only one element in this subgroup, that must be it. It just contains the identity element. All right, and if you look back at what they asked us, we have answered the question. They wanted us to find H intersect K, and we did. We came to the conclusion that H intersect K is a one-element group that just contains the identity element.